Hello everyone, in this video we are going to discuss about the selection of walls. Which type of the walls we are going to use, which time, that we are going to discuss in this video. Like when I have to go with the ball wall, when I have to go with the butterfly wall, when we are going to when I have to go with the ball wall, when I have to go with the gate wall, globe wall. So what we are going to cover in this video, first of all we will discuss about the what is wall, right? Then we will discuss about the classification of the walls, how to classify the walls on the basis of service, right? Then we will discuss about the description of the walls. About each wall we will discuss in this video. Then we will discuss about the criteria for the wall selection. What are the criteria for the wall selection that we are going to discuss in this video, right? Now before this video I have already covered so many videos about the walls. Okay, I have covered the each wall, like ball wall, gate wall, globe wall, difference between the gate wall and globe wall, difference between the gate wall and ball wall, gate wall versus plug wall. Okay, so if you haven't watched that videos, please watch that video, because I got your so many comments in that videos that sir please make the one video about the selection of the wall. So that's why here I am with the one video with selection of the walls, right? So now let's start the video with what is wall. First of all, you must know that what is the wall, why we use the wall, and what is the application of the wall in industry as well as in the your domestic application. Okay, in your home as well, what is the application of the wall? So in the piping system, like in your home also we use the piping system, right? With the help of that your water flows from the ground to the tank. Okay, in piping system, walls are the mechanical device which is used to control, restrict, on off, stop or regulate the flow or following fluid flow through the tubes or pipes, right? Now what is the meaning of it? Very simple is that in your home there is the pipelines. Okay, there is the pipelines, like in your kitchen you use the pipe. Okay, in your washroom you use the piping system, right? So why we are using that? And in that piping there is the water. Okay, most of the cases there is the water, right? Now there you are using the walls, okay, or the mechanical device you are using there. Why? To control that water flow, to restrict that water flow, to on or off the following flow of that water, right? To stop or regulate the following flow of the water. Are you getting my point, what I want to say? So that mechanical device which you are using to control, to restrict, to on off, to stop or to regulate the following fluid flow, that is the wall. Okay, that mechanical device which you are using for that purpose, that is your wall. Now it could be ball, it could be gate, it could be globe, it could be diaphragm, it could be plug, it could be butterfly, it could be needle, it could be check wall. It depends on the service, it depends on the process requirement in our industry as well as in the domestic application. Are you getting my point? What is the wall basically? Because everywhere we use the wall. Now if I discuss about the classification of the walls, so on the basis of the service you will see that we have classified the wall here. On the basis of service means here I am using the wall for the isolation service, here I am using the wall for the which purpose, here I am using the wall for which purpose or for which service, for the isolation service. Here I am using the wall for which service, for the control service or for the control purpose. Here I am using the wall for which service, for the non-written service or for the non-written purpose. Same here, the flow diversion, right? And we know that the walls are the mainly for the, mainly if I classify the wall, so wall are the linear types or the rotary types. Linear means simply there will be the wheel and you rotate that wheel anti-clockwise or clockwise, and on the basis of that walls open or close. Same, there is the rotary walls or quarter turn walls which on or off when you rotate that balls at the 90 degree, right? So that are the different things which we are discussing. But right now, if I classify the walls on the basis of service, so first wall is isolation wall, right? Now if you have to use any wall for the isolation purpose, let's suppose this is your one line and there is the one wall you have to use, okay, and there is the tank, let's suppose. Now for the isolation purpose, if you have to use any wall, so which type of the wall you can use? Simply you can use the ball wall, you can use the gate wall, you can use the diaphragm wall, you can use the butterfly wall. Now the question arises that which type of the wall you have to use. There are the 4 walls, like let's suppose I have given here the 4 walls. Now which type of the wall I have to use? So that also we will discuss in our next slide. But why I have given here that 4 walls, that is the main concern to know, right? Let's suppose if I talk about the ball wall, so you will see that the ball wall is a quarter turn wall, right? So means to on or off the ball wall is very easy. With respect to the gate wall, close the ball wall is very easy because it is a quarter turn wall. So we can simply use that wall for the isolation purpose. Same, the butterfly wall we use for the isolation purpose in the cooling water line. Why? Because there we let's suppose the delta P is not required, like delta P is, the moderate delta P is okay with us, right? As well as in the cooling water line, the gate wall also we use for the isolation purpose. Like in the main header, you will see the gate wall, right? What am I saying? So there is the different purpose, like which type of the wall you are using. Now, if you have to control the flow, let's suppose there is the line and there is the wall. Now you have to control the level of this tank. So what you can do? You can simply use here the level control wall, right? If you have to if you have to control the temperature, so simply TCV you can use here. If you have to control the pressure, PCV you can use here. If you have to control the flow, FCV you can use here. Now the reason is that, okay, so now which type of the wall you can use? Most of the time globe wall are used. Most of the time, like 80 to 90%, I have seen the globe wall as a control wall. Also I have seen the butterfly wall, ball wall and diaphragm wall in our industry. That I have personally seen. Okay, if you haven't seen, I could also tell you the application. Like the butterfly wall I have seen in the cooling water line, the ball wall I have seen in the offside plant. In the offside plant I have seen, right? The diaphragm wall I have seen in the brine line. Are you getting my point what I want to say? So that is the application of the control wall where we use. Now the same question will be arise that, sir, when I have to use the globe wall and when I have to use the butterfly wall. So there are some points which we must concern while selecting the wall, right? That I will tell you later. Now the non-return wall. Okay, what is the meaning of non-return wall? So there is the nothing. Non-return wall means, let's suppose if you are flowing fluid, let's suppose this is your pipeline. Now your flowing fluid is going in this direction, right? Now you do not want that fluid couldn't be go backward. Okay, backflow means you want to prevent the backflow, so you can simply use the non-return wall. Okay, so in the case of the non-return wall, that could be your check wall, that could be your NRV, that is the non-return wall. It could be your ball type, it could be your swing type, it could be your lift type, it could be any other type as well. Are you getting my point what I want to say? So the simple symbol of the NRV is like that, right? See here, this is your check wall or NRV. That mainly you will see where? That you will mainly see in the pump discharge line. In the centrifugal pump discharge line, you will see that there is the NRV we use to prevent the fluid, like following fluid backflow. Means you mainly want to prevent the system from the backflow. That's why we use the non-return wall. Now the flow diversion. What is the meaning of flow diversion? It means that, let's suppose there is the one line is there. Now there is the control wall. Okay, and same what you want that sometimes you want to flow the fluid from here. Let's suppose from here the fluid is flowing, right? Now what you want that sometimes you want to flow the fluid from here to here, okay, like that, and you want to close from here, right? And sometimes you want the flowing fluid to flow like that. So here you can use the three-way valve, right? Same, you can use the four-way valve, right? So that is the meaning of the flow diversion, okay? The service is a flow diversion. In that case, you can use the three-way valve, three-way plug valve, three-way ball valve, three-way or four-way plug valve, ball valve, or angle valve. Are you getting my point, what I want to say? I am trying to explain you in a layman language so that you could understood my point very easily. Now, the description of the valves, right? So there is the types of the valves and there is the application of that valves. It could be little bit different, okay, but most of the time which I have seen that I am covering in this video, okay. Let's suppose if I am discussing about the ball valve, so you will see that the ball valve is used for the shutoff application, okay, for the shutoff purpose, for the ESV and QSV purpose. ESV means emergency safety valve or quick shutdown valve, and as well as it is very suitable for the on-off duty in utility as well as in the process services. Why we are using it for the shutoff emergency like emergency safety valve or quick shutdown valve or on-off duty? Because it is a quarter turn valve. It is a quarter turn valve. Okay, so you will see that in a ball valve there is the only one handle, okay. In the ball valve you will see here there is the only handle, and what you have to do, nothing you have to do. If you want to on or off this valve, so what you have to do, you have to only turn this handle at the 90 degree. When you will turn this handle at the 90 degree, your valve will be closed or open, right? So that's why this, it means that it is very easy, or it is quick shutdown valve, because very quickly you can on or off the valve or to operate the valve, right? That's why we use the ball valve for that application. Now if you have to use any valve for this application, like for the emergency shutdown valve or quick shutdown valve or for the on off duty, simply you can prefer the ball valve, right? Same. Now for the gate valve, if I talk about, so it is used for the completely shut off valve, okay. So mainly you will see that in the cooling water header, most of the time you will see that the gate valve are preferred there, because whether you will open it for the long time or you will close it for, like in your shutdown you will close it, okay. So there you will see most of the time I have seen the shut off valve is a gate valve there, okay, and it is also mainly preferable for the on off operation in any temperature range, okay. That are the preferable which I have personally seen, okay. Now the diaphragm valve, it could be used for the on off purpose as well as in the throttling application. You can use the diaphragm valve, okay, like in the brine application, in the caustic application, or let's suppose if your fluid is corrosive, you can use the diaphragm valve, right? Same the globe valve where you are using. So in our industry the globe valve is same as a centrifugal pump, okay. In the pump there is the centrifugal pump that we use that pump. Same, the globe valve is very important for the flow regulation as well as for the shut off application, okay. Flow regulation means, let's suppose as a control valve you can use the globe valve, as the regulating purpose you can use the globe valve most of the time, okay. Same, the plug valve where you can use, it is suitable for the most of the time for the on off purpose, and when the process fluid is clean, there you can use the plug valve, okay. For the condensate line you can use the plug valve, okay, and in the utility service also you can use the plug valve. Now the next valve is a needle valve, okay, where we use the needle valve. So needle valves are mainly in a size, the needle valves are small, and the needle valve which I have seen specifically, it is used in the regulating the precise flow. Whenever you require the precise flow, okay, that time we use the needle valve, okay, and the exact calibration you want, that time we use the needle valve. It could be used in a oil line, it could be used in a gaseous and liquid line, or most of the time I have seen this needle valve in the instrumentation application. Okay, let's suppose in the control valve loop we use the needle valve, okay, because there we require the precise flow, right, in the instrument airline. The butterfly valve, it could be used for fully open or fully closed purpose, as well as for the throttling or regulating purpose. Where we use the butterfly valve, so application to application it depends, but where I have seen as a control valve, I have seen it as in a cooling water line, okay, as a control valve I have seen it, okay. Why we use it? Because simply you will see that in a butterfly valve, I have already covered the separate video about the butterfly valve, so you will see in a butterfly valve that when it is open 70 to 80% there is no problem, okay, but when it is open 20 to 30% or 40%, so delta P is high there. Or in cooling water line, what we require? Mainly we require to control the temperature of your, let's suppose the heat exchanger or any whatever the system is there. So the butterfly valves are cost efficient there, because in the disc there is the only one disc which is like that, okay. So the cost point of view, it save the cost very good, okay, and it mainly precise or it mainly control the flow in a well manner. Same if I talk about the angle valve, so it is widely used to stop or control the flow of a fluid in a pipe. That time we use the angle valve, okay, as well as to change the direction also we use the angle valve. Non-return valve I have already discussed with you. Whenever you want to prevent the flow from the backflow, you can simply use the non-return valve. Now let's see the criteria for valve selection. What are the criteria? So first of all, you will see the service of valve, like in which service you are going to use the valve, whether you are using for the controlling purpose, whether you are using for the non-return purpose, whether you are using for the on-off purpose or isolation purpose. So it depends on you, because on the basis of that you will select the valve. Let's suppose for the isolation purpose, you could go for the gate valve, you could go for the ball valve, you could go for the butterfly valve, but it depends on your service as well. Then you can go with the valve function, like at which function or what is the application, like whether you are using that valve for the throttling purpose, whether you are using that valve for the shut off purpose, or whether you are using that valve for the on off purpose, right? And after that, when you will select that and when you will select these both, so at that time like 70 to 80% you will have your 2 or 3 valve in your hand, right? Then you will go for the cost of valve, like which valve you are getting in a less price, and that valve should be good for your operation point of view, as well as it could be optimum for you. Like most of the time we do not go for the less price. Let's suppose if there is the line is a very critical line and you have to ensure that if let's suppose your valve doesn't go well, so it could be simply shut down your system, so you will not see the cost that time. You will mainly what you will see, you will see the efficiency of that valve, right? Let's suppose in a cooling water line you can go with the butterfly valve, right? But sometimes let's suppose that there is the one fluid, okay, let's suppose the viscous fluid is there, you cannot go with the butterfly valve. That time you will have to go with the globe valve, because the criticality is there. Are you getting my point, what I want to say? Then the other criteria which mainly we see, that is the fluid types, which type of the fluid you are following, okay, which type of the fluid is there which you have to handle, what is the nature of that fluid, whether it is acidic, whether it is neutral, whether it is acid or basic. Then what is the temperature and pressure range, okay, and with respect to operation and maintenance point of view also we see the the criteria. Okay, like for example, fluid types is there, like it could be liquid, steam, gas, solid and slurry. Let's suppose in a industry, every industry we use the steam, right? So in steam you will see that mainly we prefer the piston valve, because the piston valve are designed for the steam application. We also use the globe valve, but now with respect to cost point of view, piston valves are cheaper than the globe valve. So most of the time which I have seen the piston valves in a steam application, but also I have seen the globe valve as well. So it depends upon our process requirement as well. Same in a solid and slurry, I have seen the globe valve, I have seen the ball valve as well, right? Now the operation and maintenance criteria you will have to also see, like the flame resistance. Okay, that is the different thing. Leakage free, it could be definitely leakage free. Okay, let's suppose in a steam line, if you, whether like one side you are using the gate valve and another side you are using the piston valve, so there what will be the difference there with respect to the leakage, that you have to let me in the comments box. Okay, please let me in the comments box, that is also very important. Then it should be approachable as well. Okay, so the operational point of view also you have to see. Then the maintenance. Okay, let's suppose if you are using any valve there and that is again and again require the maintenance, and you are using any valve that requires the maintenance in a long period of time, so that is also the very important criteria while selecting the valve. Then easy to install and operation, that point is also very important, because let's suppose if you are using any valve and that valve, whether that valve we could like replace, or whether we could work on that valve in online or not, or whether we'll have to take the shutdown, or whether we'll have to do that maintenance, or let's suppose if I have to change that valve, so whether I'll have to do that offline or online, that is also very important. Then the fluid nature, that is very important, like whether you are using the clean fluid, slurry, suspended solid, hazardous, corrosive, viscous, falling, solidifying, that we must consider, and on the basis of that we could go for the valve, right? For the, like let's suppose for the slurry application we could go with the ball valve, but it also depends that where we are using that slurry, right? Same for the corrosive fluid, we could go with the diaphragm valve, right? We could go with the diaphragm valve, but it depends like where you are using, which type of the line is there, like whether it is your process fluid line, whether it is your off gas line, whether it is your ETP line. So okay, so that also we must consider. On the basis of that the final conclusion comes, right? So that you must know while selecting the valve. So that was the one overview video about the criteria of the valve selection. I hope you got some new point about the selection of the valves, and you got something new from this video. If you have any doubt in this video, please let me in the comments box, because I always read your all the comments, and I enjoyed when you comment and when you appreciate our hard work. Okay, so if you have any suggestion in this video, please let me in the comments box. So that's all for the today's video. Thanks for watching. Till then, keep learning.